From the purest grains of sand, a $20 billion global industry rises, transforming Earth's most ordinary material into engineered immortality. Each year, millions of quartz slabs become the polished faces of luxury kitchens and hotels worldwide. But how does raw quartz, with purity exceeding 99%, become this billion-dollar surface? Today, we step inside one of the largest quartz factories in the United States to uncover that transformation. Quartz surfaces now cover kitchens, bars, and hotels from New York to New Delhi, forming the backbone of a market that surpassed $20 billion in 2023. This industry is expanding at nearly 8% each year, fueled by the global appetite for durable, low-maintenance interiors. About 70% of all quartz slabs end up indoors, on countertops, in restaurants, and across high-traffic commercial spaces. Trade policy has redrawn the industry map. U.S. tariffs on Chinese quartz slabs, imposed between 2018 and 2020, sent shockwaves through the supply chain. American manufacturers ramped up production, investing in new factories and automation. Brands like Cambria, Caesarstone, and Elite Quartz now dominate the premium segment, while overseas producers in Vietnam, India, and Spain have increased capacity to meet shifting demand. For some, these changes have meant new jobs and local investment. For others, higher prices and reduced options. As more companies chase sustainable solutions, recycling silica waste, reusing water, and developing eco-friendly resins, the competition to deliver both quality and conscience is only intensifying. Behind every polished slab lies a story of global trade, regulatory battles, and relentless innovation. Quartz, destined for luxury surfaces, begins its journey deep in the earth, locked within thick seams of ancient rock. At open-pit mines, heavy excavators carve terraces into the hillsides, stripping away layers of soil to expose the pale, glittering quartz beneath. Massive 100-ton haul trucks rumble across the site, loaded with rough ore that will soon be transformed into a prized industrial ingredient. Geologists on site use mineral mapping to target the richest veins, ensuring every blast yields material of the highest purity. Each load is delivered to a nearby crushing facility, where the ore is broken down in stages, first by jaw crushers, then by vibrating screens, until only fragments a few millimeters across remain. Water and chemical baths wash away any lingering impurities, pushing the quartz content above 99% silicon dioxide. Only this ultra-clean quartz, free from iron stains or clay, meets the strict standards required by slab factories. The result? A mountain's worth of raw crystal, now refined and uniform, ready to enter the next phase of its transformation from mineral to engineered stone. Inside the mixing hall, control system operators monitor screens as quartz fragments, now refined to over 99% purity, are loaded into enormous hoppers. Automated batching computers weigh and dose each particle size with precision, maintaining the industry standard blend, roughly 93% quartz to 7% polyester resin, pigments, and specialty additives. This exact ratio is critical. Too much resin and the slab loses strength. Too little and the mix won't bind, risking cracks later on. The resin itself acts as a molecular glue, forming a polymer network around every grain. In advanced formulas, the chemistry is tweaked for better heat resistance and color stability, a response to both consumer demand and regulatory pressure. Pigments, and, in premium lines, fragments of recycled glass or mother of pearl are introduced at this stage, setting the foundation for later design work. Environmental controls are strict. Humidity must stay below 40% and temperature near 25 degrees Celsius. Even a small fluctuation can throw off curing times or cause surface defects, so the air is filtered and conditioned around the clock. Operators adjust for seasonal changes, relying on real-time data to keep every batch within tight tolerances. This careful orchestration delivers a uniform, air-free mixture, chemically stable and ready for shaping. With global demand rising and forecasts pointing to a $25 billion market by 2025, factories invest heavily in these systems. The result is not just consistency, but the ability to scale production without sacrificing quality, setting the stage for the artistry and engineering that follows. A continuous ribbon of quartz blende moves along the spreading line, guided by synchronized laser sensors. Vibratory tables beneath the conveyor hum at carefully calibrated frequencies, coaxing the mixture into a perfectly level bed. Uniformity here is essential. The slightest variation could ripple through the slab, undermining both strength and appearance. Next, the choreography of design begins. Computer numerical control, or CNC, veining machines glide overhead, their nozzles injecting precise streams of pigment deep into the quartz resin mix. Every motion is programmed, yet the result mimics the unpredictable beauty of natural marble. Some slabs receive bold, branching veins, others delicate wisps. The secret lies in digital vein codes, custom algorithms that dictate every swirl and streak. These codes are archived, allowing factories to replicate a signature look across thousands of slabs, or to create one-of-a-kind patterns for bespoke projects. For the most exclusive lines, artisans step in, adding hand-finished touches that machines cannot achieve. A subtle flick of pigment here, a feathered edge there. These details transform a surface from industrial product to luxury statement. Each recipe, whether mass-produced or hand-finished, is stored in the plant's digital library, ensuring consistency or variation on demand. Sustainability is engineered into this artistry. More than 90% of the water used in mixing and cleaning cycles is reclaimed and filtered in a closed loop, reducing both environmental impact and operating costs. In this phase, design and technology merge, setting the stage for the raw slab to become both a work of art and a feat of engineering. A slab's final character is forged inside the vacuum vibro-compression chamber, where raw mixture meets the full force of modern engineering. Hydraulic rams descend with over 100 metric tons of pressure, sealing the mold beneath steel and glass. At the same moment, industrial pumps evacuate the air, dropping pressure inside the chamber to less than 20 millibars, so low that even microscopic bubbles are drawn from the resin. High-frequency vibrators pulse through the mold, shaking the mixture at up to 60 cycles per second. Each vibration helps quartz grains settle into a tighter, more uniform structure, while the resin flows into every gap, binding the slab from the inside out. Sensor arrays track every variable: pressure, vibration, temperature, vacuum integrity. Any deviation triggers an automatic halt, protecting the slab from hidden flaws. In less than 3 minutes, the transformation is complete. The loose, patterned bed emerges as a dense, cohesive slab, its strength and uniformity locked in by physics, its design preserved for decades of use. Inside the thermal chamber, each slab is exposed to temperatures between 200 and 250 degrees Fahrenheit. This controlled heat triggers the resin to polymerize, bonding tightly with the quartz and locking in the slab structure. Gradual cooling follows, preventing thermal shock and ensuring the surface remains free of internal stress or micro cracks. Diamond-tipped saws then trim the cured slabs with precision, achieving tolerances within 1/16 of an inch. Multiple polishing stages follow, using fine diamond abrasives to produce either a mirror-like shine or a soft matte finish. Throughout, water jets keep the surface cool and dust-free, preserving both appearance and integrity. Quality assurance teams rely on advanced laser scanners to detect even the smallest flaws, imperfections invisible to the naked eye. Manual checks confirm surface gloss and tactile smoothness. Only slabs that meet strict standards for scratch resistance, non-porosity, and heat tolerance are approved. Each finished piece receives a protective film and is carefully racked, ready for shipment to projects around the world. In 2023, the engineered quartz industry reached a global value of over $20 billion, fueled by demand for surfaces that blend durability with design. This documentary has traced each step, from open-pit mines delivering quartz at over 99% purity, to factories where automated systems, digital veining, and vacuum vibrocompression transform raw minerals into luxury slabs. Yet, not every detail is public. The full list of proprietary resin blends and the most advanced sensor algorithms remain company secrets, and the long-term environmental impact of silica mining is still under study. What is clear, anti-dumping tariffs have shifted production, sustaining American jobs while raising questions about global trade. Today, engineered quartz surfaces appear in homes and hotels worldwide, products of decades-old inventions, precise engineering, and relentless market growth. The journey from sand to slab is a testament to technical progress and global demand documented in every polished surface shipped around the world.